Hello, and welcome to Madison's Chemistry. Today we're going to be talking about G protein coupled receptors, which are one of the main types of receptors for biochemistry. So let's first start by just looking at this diagram up at the top. So what we can see is that there's 7 transmembrane domains. And that's a standard fact for all G protein coupled receptors. So first we're going to look at this diagram with the ligand unbound. So let's take our ligand and let's put it pretty far away so we can tell that it's currently not bound. And what we'll see is that with this transmembrane domain, we also have the alpha, beta, and gamma units of the G protein. So this right here is our G protein. Okay, so now, as soon as our ligand binds, we're now going to have GTP bound instead. And when this GTP is bound, we can actually go and do stuff, right? This is what's going to bind and do stuff. And there is going to be a way to bring this back into the inactive form. So this is inactive, active. Okay, we'll go over how to convert this to and from in just a moment. Okay, so let's go over the specific pathway. This is going to be the norepinephrine or epinephrine pathway. So this is going to be active in fight or flight scenarios. So let's have the beta and gamma proteins still bound here, and this alpha and GTP is here, and let's say that our ligand is already bound. Okay, so this alpha subunit is going to go bind to our adenylyl cyclase. So let's draw that. So we've got our alpha bound to our GTP. And as soon as this binds, this is going to activate our cyclic AMP, or our adenylyl cyclase, which is going to convert AMP to cyclic AMP. And so, once we make this cyclic AMP, it can go activate pKa. So it's going to have 2 cyclic AMPs bind on the left side, and 2 cyclic AMPs bind on the right side, so we're going to get a total of 4 cyclic AMPs to 1 pKa. Okay, and so what exactly is this going to do once this is bound? So because this pathway is the norepinephrine-epinephrine pathway, we're going to mobilize glucose for muscle contraction to help us, run away from whoever's chasing us when we have that fight or flight reaction. Okay, so now obviously we don't want to have this pathway active all the time, especially in the case of specifically just for fight or flight. That's not a reaction we want all the time. That's obviously not healthy. So how are we going to inhibit this pathway? So that's what we're going to talk about right now. So the first way is this natural GTPase activity, which basically just means that GTP can freely go back to GDP. So it can easily go from the active to the inactive state on its own. So that's a pretty good way for it to inactivate this pathway. The second way is through arrestin. So arrestin is going to bind to the Gpcr, and it's going to inhibit it, or inhibit the Gpcr. So therefore, this is going to inhibit the ability for us to go into the active form and make this alpha GTP unit, which can then go activate other stuff. So arrestin is very powerful because it can stop it in its tracks and not allow it to go into the active form. And then our third way is this phosphodiesterase molecule. And it can actually convert cyclic AMP back into AMP, thus preventing pKa from getting activated. And that's very powerful because the thing that's actually controlling everything and doing things in our bodies, such as mobilizing glucose, is the pKa itself. So if we can't activate pKa, we're not leading to those classic outcomes that we're looking for. So it's a way to prevent the outcome. These are all obviously ways to prevent the outcome, just varying levels of where we're going to be stopping the thing from occurring. Okay, so that's all I've got on G protein coupled receptors. I hope that this video was informative and helpful.